Hello folks, the question for today is 2015 May-June paper 1-3 and the question number is 30. This question is concerned with the topic electric field. So it says that a molecule behaves as an electric dipole consisting of two equal point charges of opposite sign. So of course yes, separated by a distance. So a dipole always has two equal charges, most preferably point charges of opposite sign, and they are at some distance. The molecule moves with a constant horizontal velocity as it enters a vertical uniform electric field. So this is the direction of movement of molecule, which is horizontal, and this is the vertical electric field. The positive and negative charges of the molecule enter the field at the same time. So these two things enter at the same time. So since it is placed somewhat like this, it is elongated somewhat like this, so they enter the field at the same time. So had they been like this, the positive would have entered first and the negative later. Had they been like this, the negative would have gone first and the positive later. But since it goes like this, both of them enter at the same time. That means the force on the charges will happen at the same time. Which row describes the velocity of the molecule in the field? Which row describes the velocity of the molecule in the field? So we have to find what happens to the velocity. So now what happens is, since the electric field is like this, here we have got a positive charged positive charges, and here we have got negative charges. So now what happens is, when this enter, the negative charge will feel attractive force here, and repulsive from here. So resultant force will be here. This is for negative charge. And the positive charge will feel force here. It's because positive here, negative here. So for positive, force here, and for negative, force here. And both of them will be equal because they are equal, making the whole thing zero, the whole charge zero. So both the forces are equal. So that means the force resultant will be equal to 0. So in the vertical direction, the force resultant should be equal to 0. So that means the vertical component of velocity will be 0. It neither goes like this, it nor goes like this. So the vertical component of velocity should be 0. So that means we have B and D are there, and A and C disqualify in the very beginning. A and C disqualify, only B and D remains. Now let's talk about the horizontal. So to have that thing here, the only force here is in this direction or this direction, and there is no force in the horizontal direction. So that means there is no acceleration or retardation of this thing. So that means the horizontal component of the velocity should be same as before. It doesn't increase, it doesn't decrease. So that's why this component of velocity should be same as before. So that's why this also disqualifies, and this should be the correct answer. Horizontal component constant, vertical component 0.